Alright, we're back again with Math 170, making a video about the MyLab Math Assignment 2.4, and this is problem 3. And so this is the problem I got. And basically what it gives me is it gives me a piecewise function that's called f of x. And if it's been a while, this is a piecewise function, and what it describes is the function will be this function, and then comma for these values. So in other words, this function f of x will be the square root of 16 minus x squared only when x is less than or equal to 0 or less than 4. Then the function is 4 when x is less than or equal, when x is greater than or equal to 4 and less than 8. And then the function is 8 when x equals 8. So let's go ahead and graph it. Here's my x-axis and my y-axis. And we'll start with the lowest part on the graph. It's root 16 minus x all under the square root. If you don't recognize it, it's a circle. And that circle is going to be radius 4. And so, we know that it's centered about the origin, because there's no shifters in there. And so it starts 4 up, 2, 3, 4 up. Actually, let me make my scale a little smaller. So 1, 2, 3, 4 up. And it includes 0. So we fill in a dot to indicate that 0 is included in this function. Then we're going to have a circle that goes over to 4, but it does not include 4. So we leave an open circle to show that the set does not include 4. Then for the next step, the function of x is 4 when x is between 4 and 8. And so we're going up to 4 pi, and it includes this function when x is 4, greater than or equal to 4, all the way up to 8, not including 8. So 1, 2, 3, 4 from 4 is 8, and we've just got a flat line equal to 4 while x is between 4 and 8. Then the last step is that when x is 8, the function, when x is 8, the function outputs 8. So now we have to go 1, 2, 3, 4 above 4, and at 8, it equals 8. And that's a filled in hole to indicate that it's included in this part of the function. Now, the first part of this problem is asking what is the domain and range. And so, the domain and range, domain represents what are the values that this function f of x, what values of x are included in this function. In other words, for what values of x will there be a y output for this function. And so to find that, what we do is we're going to look. So obviously the graph doesn't go into the negative numbers. F of x says nothing about negative numbers. But we are including, if you have x equals 0, that has an output. It's 4. So our domain goes to and includes x equals 0. So we do the square bracket to indicate that it's included in the set, in the domain. And we'll notice that as x goes over here, there's an empty hole, which represents that x value is not included. However, even though it's discontinuous, in other words, it's very jumpy, if you put in 4 to the equation f of x, you will get an output. Even though it's not this output, you will get an output, and therefore 4 is also included in the set. Then we keep going, and once again there's an empty circle, so this function doesn't say anything about when x equals 8, but our function says something about when x equals 8, so 8 is also included in the set. So there's our domain. We go from 0 to 8. Now the range is basically the opposite of the domain. The domain, we're looking at what inputs will give us an output. And range is looking at what outputs exist for this function. And so now instead of scanning the x-axis, we're going to scan the y. And so we start down here at 0. And we'll notice that there's no filled in part of the graph when y equals 0. there's an empty hole there, so that doesn't count. So our range starts at, but does not include 0. So we use a parenthesis to show that 0 is not included in our range. Then we move up and we'll find that it's continuous all the way up to 4 and includes 4 in several places. But after 4, there's nothing all the way till 8. So we're making it to 4, and we're including 4 because there's filled in holes at 4. And then the symbol that tells us we're skipping is called the union. And it's a big upside down U. And what that indicates is that between 4 and the next part of the set, there is no set. So in other words, there's nothing included. There's nothing happening between 4 and 8, not including 4 and 8. So that's what the union is representing, is that gap there. And so then we go up further, and at the end of the union, we have an output of 8, right? An output of 8. And so 8 is included in the set, but nothing around it is included. So on MyMathLab, what they use to indicate that, so in other words, we're indicating a single number, not some range of numbers, but a single number that's included in a range. Instead of using the square brackets, they actually use these squiggly brackets to indicate that it's a single number, and only that number is included. So here's our domain and range, and so we just solved problem number A. Now we have to determine for what C a limit exists. What they mean by C is some x. I don't know why they don't just say that. So in other words, we're looking for what x values does a true limit exist. And if you've watched my limit video, you will remember that to find out if a limit truly exists, we have to approach the point from the left and from the right. So in other words, there's the negative testing of the limit and the positive testing of the limit. If those left and right-handed limits agree on a number, then the limit does exist for that point. If those right-handed and left-handed limits for a point don't agree, then it's not a true limit. So, let's start here. If we're taking this function and we're approaching the end of this function from the right, we're approaching an output of 4. What about if we approach it from the left? We can't approach it from the left. And so, does not exist left-handed limit. 4 for right-handed limit, those aren't agreed. So there's no limit at this point. However, even just a little bit away from that point, an infinitesimal amount of distance away from that point, you can now approach it from the left and right. And if you approach a continuous curve such as this one, from the left and the right, you are going to find a true limit. And so, let's take some arbitrary point in here. If I approach this from the right, I'm approaching the same value as if I approach it from the left. And so we know for a fact that for answer for B, that a limit will exist any place in a graph that's continuous like this. So in other words, not choppy. So limits do exist. Let me write that down. Limits exist. And then we're going to write this in interval notation. So at x equals 0, there is no limit because the left hand disagrees with the right hand. But any number above 0, all the way to 4, all the way to x equals 4, will have a limit. Not including 4, however, because if we approach 4 from the left, we'll find that y is approaching 0. If we approach 4 from the right, we'll find that y is approaching 4. 0 doesn't equal 4, therefore there's no limit at 4. And now we're going to have a union. And any continuous part of a graph will have a limit at every point. So not including 4, because we just argued that 4 doesn't have a true limit. But all this straight line segment is a continuous graph. So as we follow that line, if we approach numbers from the left to the right, you're going to find a limit. And that takes us all the way to 8. But not including 8. Because if we approach 8 from over here, we're approaching 8. And as we approach 8 from over here, we're approaching 4. So this is, for problem number B, this is the range for which true limits, or not the range, this is the interval for which true limits exist. So there's A, here's B. You got a couple more problems left. Now it's going to ask us to determine point C, or X values, where only left-handed limits exist, and then the next problem is the same question for when only right-handed limits exist. And you'll notice that here, let's start over here at 0. If I approach from a left hand, that limit is undefined. So there's no left-handed limit here because there's no graph to approach 0 from on this side. Whereas on this side, you do have a right-handed limit for x equals 0. So there are right-handed limits. I'm going to write that down as RHL for right-handed limits. We do have right-handed limits when x equals 0. But everywhere else, like at this point, there's a left and right-handed limit. All the way over to here, where there's a left-handed limit, but there's no graph over here to tell us what a right-handed limit would look like. And so therefore, for x equals 8, there's only left-handed limits at x equals 8. So there's C and D. I hope this was helpful. If you're a bit confused, I recommend going and watching my original limit video. It doesn't dive too deep into this, but I think it'll help with some of the misconceptions. Just remember that a limit is not plugging in a value and getting another value out. A limit is getting closer and closer and closer and closer to the point from both sides. And wherever those sides seem to be getting closer to, that's the limit. And so that's just something to remember. I hope this was useful, and I'll see you next video.